global section, there's 158 lines in the directory, 109 lines in the parameter section, and there's 1 line in the terminal section. And the IGES readers and writers actually track the number of lines. So if you go in there and just arbitrarily edit an IGES file, it won't be readable by any reader. They have developed editors, IGES editors, for you to go in and tweak things, but you can't just go into Word or into some ANSI notepad or something like that and trying to edit this thing to be successful at it. It will crash the file. So the question is really, why did we take 10, 15 minutes to go through this? Okay. Well, hopefully this is the answer. It is the most widely used system for moving data here in the United States. It is slowly changing, okay? But if you go into a company and they say, send this file, typically the file they're sending is going to be an IGES file, okay? In previous semesters, when we have kind of interacted with the remote students and asked them what is used in their country, most of them indicate that their countries are moving towards Sept. That's the next thing that we're going to be talking about, is the Sept translator. Okay. What I would challenge you to do, both the BYU students and the remote students, is the next time you connect up, one of the things I want you to do is talk about how you're going to move data. Now, not move data from your NX system or your CATIA system to your remote students' NX or CATIA, because that's just that's a file. You hand them your file, they hand you your file. No translation. But if somebody remote to you is going to start working inside of HyperMesh, does HyperMesh just open up ARCAD files, or do we need to do something, translate them, so that they can be read into HyperMesh? So you're going to want to talk with your team members and find out what standard, what approach, what method do you want to use to translate data. The second reason that I think this was worth talking about is it demonstrates that the IGES standard is very, very well documented, okay? It wouldn't take very much for you to go into a company that had a proprietary piece of code and they said, we want to be able to import geometry. It wouldn't take very much for you to write a reader using C++, C in, C out, using some simple algorithm. You can input data, you can either import or export data very easily to CAD systems that don't have IGES built into them. And most of those systems are the proprietary code sitting inside of companies. The last reason is basically, you know, if you ever need to figure out why you sent a file, but the file didn't make it there, or all of the data didn't make it there, you can easily go in there and say, you look at the text document, and you say, gee, I have 80% of this that's a 106. Is it any surprise that 80% of your data didn't make it to the other system? It shouldn't be. You can just look in there and say, how much copious data do I have? And if it's copious data, it's not making it to the other side. And so you can investigate how clean your text file is just by opening it up and looking at it. A simple little check before you hand it off to somebody. So the next thing we want to look at is Sept. And we're only going to take a few seconds on each of these other topics. STEP is controlled by ISO 10303. Okay? It is an international standard. It is well developed. It has these things that are called application protocols. And so there's an application protocol for mechanical design that covers modeling, it covers drafting, it covers sheet metal, it covers a lot of different mechanical aspects. There's also protocols for doing shipbuilding, for doing manufacturing, for doing electrical stuff, for doing PLM. And so if you hold the STEP standard up compared to the IGES standard, you're going to find that it's 5 times, 10 times the standard. Just if you were to print out page by page, the STEP standard is huge by comparison to the IGES standard. And the reason for that is because it covers things that IGES never even dreamt of covering. Okay? All of the new modeling styles and techniques and history files and everything else. So inside of this PowerPoint that's going to be uploaded to TCC or should be uploaded to TCC, there's this link. If you ever want to kind of go and look at the STEP standard, click on it. It reads like an encyclopedia. But still, you can go in there and you can find information on how to develop a reader or a writer. This is the actual text file of a STEP output. Okay? Does it look like it's as organized as what we just went through in IGES? You can't read that, but it's in your books. It's a page ripped out of your book. If you were to kind of glance at this top information, you would say, oh, that's kind of like the man-readable start information. It's also kind of like the global, information. As you get down into the body of this, what you'll find out is they've kind of taken the directory and the parameter, and what have they done? They just mushed them together, okay? Instead of in the directory section, there was a pointer in the directory section that said, if you want to find the beginning and end point of this line, go down to this line in the parameter section. So there was a forward pointer that would loop you down there. In setting up this standard, they said, that's nonsense. Why don't we just put them together and put them on the same line? And so that's basically the organization of this file. Okay. STL, another neutral file format. STL is basically a file format for doing rapid prototyping. Stereolithography was kind of the first rapid prototyping machine. And they would take a CAD part and they would turn it into triangles. So every exterior surface of the part, either internal or external, were turned into triangles. And then they would slice through the triangles with planes, and those planar cuts would then be sent off to a stereolithography machine, and they would basically cure the material, and it would sink down into the vat, and they would cure another layer, and it would sink down. But it was all off of triangular representation of the data. So if you say output an STL, can you take that STL and go to another CAD system and say, bring it in? You can. What are you going to get? Triangles. But it is a way to move the model to another system. DXF and DWG, those are basically translation programs for moving 2D data. Primarily drawing data is what they were set up to do. Okay. Do they have a standard? Yes. Do they have a format that you can open up and look at? Yes. It's just that data.
What programs you open up in DWG is pretty much
It's any CAD system that has kind of a AutoCAD developed DXF and DWG both. So it's any company that has kind of said, we can read AutoCAD data or want to read AutoCAD data that basically developer reader